The reason why we have conic section is because circles are derived from the circular base of a cone. So that section of a cone is what we are going to discuss, which is the circle. A circle is a locus of points, equidistant from a fixed point known as its center. So we are going to study equation of a circle, know all the chords of the circle, beginning from the diameter, which is the largest chord of a circle, to other subchords like the radius, secants, and other things, chords of a circle. All right, so there's a question on the board, and we are going to study that question and solve it carefully to obtain the result. The question goes, a circle is given by the equation x squared plus y squared equals to 6x minus 8y plus 25. That represents a circle. Now the question goes, find the center and radius. That's the first question. You also find the equation of tangent to the circle at the points 1, 2. And also find the equation of the normal to the circle at 2, minus 3. So we pick the first question. A. First of all, we write the equation. We are going to rearrange the equation to be in the general form of equation of a circle. So that will be packing everything from this side to this side. So allowing 0 to be on the right hand side. So we have x squared plus y squared minus 6x plus 8y minus 25 equals to 0. So this represents the general form of equation of a circle. So we are looking for center. What we mean by center is coordinate of the center of the circle. Now, let's see. This equation, we have to compare it with the general form. X squared plus y squared plus 2gx plus 2fy plus c equals to 0. Then we get the parameters. Comparing this general form to the given equation, we will have that our 2g will become minus 6. Our 2f equals to 8. While our C constant will be minus 25. Alright, so determining the value of G, our G will give us minus 3, our F will give us from here, will give us 4, and our C is still minus 25. So the coordinate of the center is given as minus G, minus F. So substituting these variables, we will have our center as what? Put minus where you have minus 3, you have 3. Put minus where you have f, you have minus 4. So this is the answer for the coordinate of the center of the circle. Thank you very much. Happy viewing. Right, still on that same question, the big part of it goes as follows. To find the equation of tangent to the circle at these given points. We want to find the equation of tangent to that circle. A tangent is a straight line that touches a circle at a particular point called point of tangency. That point of contact is called point of tangency. So we want to find the equation of that straight line, that tangent. So let's see what we're passing through this point. But remember, the equation of the circle we obtained was x squared plus y squared minus 6x plus 8y minus 25 equals to 0. That was the given circle. So, to find the equation of tangent to this circle at this point, first of all, we are going to apply differential calculus, what we call differentiation, and getting the equation of tangent. That is, we need to find the tangent, the gradient of the tangent of the line. The gradient of the tangent of the. So we differentiate this implicitly. So we put that differentiating implicitly, we have differentiating implicitly, you have 2x with respect to x. Differentiating this implicitly, you have 2y with respect to y. That is it. Differentiating minus 6, so you have minus 6 with respect to x. Differentiating 8y, you have plus 8 with respect to y. Differentiating 25 is 0. equals to differentiating 0 is 0. That is an implicit differentiation to it. But we are going to allow with respect to y to be on the left, with respect to x should go on the right. So we arrange it properly. With respect to y, how many with respect to y do we have? Oh, this was with respect to y, differentiating y to have 2y, that was with respect to y. So we allow this and this to be on the same side. So we have 2y dy plus 8 dy, taking with respect to x to the right. So this to the right will become positive 6 with respect to x. Then taking this to that side, so we have minus 2x with respect to x. Then factorizing each of the common terms, you have dy open bracket 2y plus 8 for the left. Then for the right, the x is common. You have 6 minus 2x. What we are interested here is the gradient, which is dy dx. So we develop by saying dy dx. This will go to the bottom of this to become dy dx. And this will go to the bottom of this. We will now have 6 minus 2x over 2y plus 8. That is the gradient function. What we are going to use to determine the gradient of the tangent of that line. Now, substituting these points for x and y respectively, we are going to have the differential value of the gradient. Substituting it here. At x equals to 1, we put 1 here. So definitely we have 6 minus 2. That gives us 4. Over 2y plus 8. 2 times 2, 4. 4 plus 8. We have what? 12. Of course, we have that. Then reducing that, that is 1/10. Now the gradient of the line will be given from, will be getting the tangent that touches the circle at this point will be obtained from this. Our dy dx equals to y minus y1 over x minus x1. x1, y1 is this. So the gradient will have a differential value. Therefore, 1 over 3 will now become y minus, our y1 there is 2 over x minus x1, and our x1 there is 1. So cross multiply, the answer will come out. 3 into y minus 2 equals to 1 into x minus 1. Open up the bracket, we have 3y minus 6 equals to x minus 1. Collecting like terms, making it neat. Therefore, the tangent of that line will become 3y minus x equals to 6 minus 1. That becomes 5. So this is the correct tangent of that line. This time around, the C part of the equation has it that we need to find the equation of normal to the circle, to that circle, that same circle. But at this point, solution. We got the tangential value of the gradients for the second question. The tangential value of the gradient gave us dy dx equals to 1 over 3. If you can recall, you got 1 over 3 as the tangential gradient. Then for the normal, the normal is the same thing as the perpendicular line, gradient of a perpendicular line. So this will take up the negative reciprocal. For the normal, we have something like this, dx minus dx over dy, which will give us the negative reciprocal of this, and that is minus 3. And that minus 3 will be joined with this point because it passes through this point. Y minus y1 over x minus x1. So we substitute the points accordingly. Minus 3 equals to y minus y1. y1 here is minus 3. So minus and minus becomes plus. Over x minus x1, which is 2. Cross multiply, our y plus 3 will be equal to minus 3, open bracket, x minus 2. Open up the bracket, y plus 3 will become minus 3x plus 6. Back everything to this side, we have 3x plus y equals to 6 minus 3. So the equation in a general form, thereabout will be 3x plus y equals to 3. Because 6 minus 3 is 3. And that is the answer, because this is going to be the equation of normal to this circle, but passes through this point. That is 3x plus y equals to 3. Have a nice time.